Alrighty, folks. Today we are going to talk about the periodic table, and right here in front of you, we are looking at a periodic table. I'm sure you've seen one before on the wall of your science classrooms in the past, and maybe you even have one with you right now. I hope you do, actually. It'd be really helpful if you had your periodic table out and ready to go. So, with that being said, let's talk about the periodic table. So, to set up our notes for today, our topic is periodic table, and our essential question is, what are the patterns of the periodic table? Go ahead and pause the video, get your notes set up, and then come on back and we'll get started. Our learning target for today is I understand the arrangement and patterns of the elements in the periodic table. All right, so let's go ahead and start with the very most kind of foundational structural piece of the periodic table, and that is the periodic table is arranged by the number of protons. So we did this simulation earlier, and what you noticed is each time you added a proton to your atom, it changed the identity of the atom, and it moved one up the periodic table. So this is helium with two atoms. If you added another atom, all of a sudden we would be number 3 on the periodic table, lithium. If you added another atom, we would be number 4, beryllium, so on and so forth until you get to 118. I believe that's called oganesson or something like that. But yeah, each time you add an atom or add a proton to an atom, it moves it one up the periodic table. So the number of protons equals the atomic number, and the atomic number is going to be where it gets placed on the periodic table. So as the number of protons changes, the element changes. All right, so that's our overall organizing structure. Is the atoms are laid out in increasing atomic number. Next, we place the atoms into horizontal rows called periods. So a period is the horizontal row of elements on the periodic table, and we also place them into vertical columns called groups. A group is the vertical column of elements on the periodic table. Now, how are you going to remember which one is a period and which one is a group? Well, in the English language, we read our sentences from left to right, and sentences end with a period. So when you are looking at the periodic table and you're moving from left to right, you are looking at a period, and then your vertical columns are going to be your groups. What question do the previous slides answer? All right, so when we are looking at periods, there's actually a couple of patterns that we take note of when we are looking at periods, and these are going to be consistent for all of the periods. Some of them are pretty straightforward. Actually, most of them are pretty straightforward and things that just kind of like, as you look, it's like, oh yeah, that's just kind of how it's organized. So what are the patterns for your periods? Well, as you go from left to right, the atomic number increases, the number of protons increases, the number of electrons increases, and the atomic mass increases. So just stop and think about that real quick. That should make sense because as we move from left to right on the periodic table, the atomic number increases because each time you take a step right, you're going up an element. So if the atomic number is increasing, that means the number of protons is increasing because they're the same thing. If the number of protons increases, the number of electrons has to match that. So once again, that's the same thing. And as you increase the number of protons, that means that you are increasing the mass of the element, and so the atomic mass increases as well. Now, the thing that stays the same for each period is going to be the energy level. So the number of energy levels of electrons. So for each period, there is only a single, or there is or they are all the same energy level. So in this first red period here, every element has one energy level. In the orange period, every element has 2 energy levels. In the yellow period, every element has 3 energy levels, so on and so forth. So there are your period patterns. What question does the previous slide answer? All right, so now let's talk about those vertical columns. And we defined this term earlier, but this is super important. And this is actually going to guide us through the rest of our discussion about chemistry, really for the entire semester. And that is valence electrons. And remember, these are the electrons in the outermost shell. So a couple of lessons ago, we filled out this Lewis dot diagram periodic table. And what we noticed when we did it is that all of the elements in each column have the same number of valence electrons. So in this first column, they have 1, second column 2, third column 3, 4, 5, 6, 7, and full. So groups have the same number of valence electrons. So that's true up here as well. This is actually organized in the same manner as the periodic table. So hydrogen, lithium, sodium, and potassium, they all have 1 valence electron. Beryllium, magnesium, and calcium, they all have 2. Now, very important thing here. We skip over this light blue section called the transition metals and this purple section, the lanthanide and actinide series. When you get down there to those, valence electrons get all kinds of weird. So we're not going to do that in this class. Instead, we're just going to focus mostly on the first 20 elements and their groups. So everything with boron, aluminum, gallium, indium, these all have 3 valence electrons. Carbon, silicon, germanium, tin, lead, they all have 4. Nitrogen, phosphorus, arsenic, antimony, and bismuth, they all have 5. Oxygen, sulfur, selenium, tellurium, and polonium, they all have 6. Fluorine, chlorine, bromine, iodine, they all have 7. And then your noble gases, helium, neon, argon, krypton, xenon, and radon, they all have a full outer valence shell. So you could think of them as having 8 or 2 with helium in helium's case, or you can just think of them as having 0 valence electrons because their outermost shell is full, and so they don't really have any valence electrons to share. But the fact that each of these and then also above each column on the periodic table, there's usually a Roman numeral or a number followed by the letter A, and that number is going to tell you the number of valence electrons in that column. Or you could just count 1, 2, 3, 4, 5, 6, 7, 8. However you want to do it. Regardless, the similar numbers of valence electrons having the same number of valence electrons gives all of the elements in a group similar chemical properties, which we're going to talk about more in our next lesson. What question does the previous slide answer? Alrighty, folks. So I want you to go ahead and turn in your packet, and once you turn, you will find a blank periodic table that looks like this. We are going to use this for today's lesson and the next lesson, and we are going to be making a color-coded periodic table. Now, here's the really important thing to remember as you fill this out. Don't go through and color in each box. Focus more on kind of outlining boxes or groups of boxes because sometimes colors are going to overlap and we want to make sure that we can indicate when something is part of more than one section or group. So hopefully you have this in front of you because we're going to do our first kind of grouping of the periodic table. And that is the 3 major sections of the periodic table. So you can see them here in blue, green, and yellow. Metals are going to be on the left-hand side of the periodic table, and they are all of these ones that are in blue. Nonmetals are on the right-hand side of the periodic table, and they are all the ones in yellow. And then metalloids is this staircase between metals and nonmetals, and those are in green here. So I want you to go ahead and fill in or outline these sections on your coloring periodic table. Now, really, really important thing. Hydrogen's weird. Hydrogen, it acts in a lot of very strange ways. So hydrogen actually behaves very, very similarly to all of the atoms in this group, which is why oftentimes it's over here. However, hydrogen's not a metal. Hydrogen is a gas. So we actually have that qualified as a nonmetal. Hydrogen also behaves very similarly to the atoms or the elements in this group right here. And so Hydrogen kind of has, it can be placed multiple places on the periodic table. We tend to place it in this top left-hand corner, but you do need to remember that hydrogen, even though it's on the left-hand side of the periodic table, it is a non-metal. So make sure that you indicate that. What question does the previous slide answer? Alrighty, folks, I want you to go ahead and pause this video, take a 4-question ungraded quiz, and see how you do. Once you've finished taking the quiz, come back and we'll answer the questions. Which of the following stays the same as you move across a period? That is going to be energy level, protons, atomic number, and electrons all increase as you move across a period. Which of the elements are on the right side of the periodic table? Elements in red in this this diagram I gave you. On the right-hand side, that is going to be nonmetals. Vertical columns on the periodic table are called groups. And elements with the same number of valence electrons tend to be in the same group or vertical column. So if you answered those 4 questions like that, then you should have gotten 100%. Alrighty, folks, take a quick moment to self-assess on a scale of 1 to 5. How well do you understand the arrangement of the periodic table? 1 is I'm super lost. 5 is I could teach this better than you, old man. So hopefully you got this. If there's something you're confused about, you can go back and rewatch parts of the video. Or as always, please feel free to reach out to your teacher and we will be very happy to help. Have a great day.